Okay, good morning. Good morning. We've talked about percentages, yes? We were just talking about how to use that. Did we end up about on this one here? Just where we ended up with? Okay. First of all, before we start, what questions do you have? What questions do you have? What's not making sense? To do well, if you're a little foggy in the head or something's not making sense, you need to get help. You need to come and get help. You need to get over that. I know some of you are just, you're just starting college and but really to be successful, you got to come and get help. You got to come and get help, okay? You just can't come and sit and pretend it's going to get better, because it's not going to. Okay, so you just need to get help, and then you'll understand what we're doing and you're going to feel good about what we're doing. Yeah. Yeah, I couldn't hear what you said.
I don't know, really.
Could I do a problem with what?
Yeah, he's wanting the cubic meters to cubic centimeters.
Oh, cubic meters to cubic centimeters. Okay. Did we skip over that for some reason, or did we? Because we're gonna. Yeah. Okay. So it's coming up. Coming up. Yeah. So we're gonna get to that. We're just a couple slides right before that. Okay. But yeah, that's a little tricky on how we do that, but thank you. Okay, so let's take a look. This is an example of how we use percentage in a problem. If we're trying to calculate the percent of something, we just it's just the, what we're interested in divided by the total, times 100. But a lot of problems, they give you the percent, and we have to know how we're going to use that in a problem. So here it says, how many fluid ounces of alcohol are in a 1.0 bottle? 1.0 bottle of wine that has 12% alcohol by volume. Okay? And because we're talking about fluid ounces here, that's a conversion that we don't typically use. And so here it's given to us. A milliliter is equal to 29.57. Fluid ounce is equal to 29.57 milliliters. Okay? So how we're going to use this 12? The percent here is always 12 out of 100. 12 out of 100. And if it's percent by volume, that means there's 12 milliliters of alcohol per every 100 milliliters of wine. That's our conversion. So that's what 12% means. Okay, that's how we're going to use it in our problem. And we're going to set up this conversion so that the units are going to cancel out. Okay? Where do we start? That's a big problem. I mean, that's a big issue for people, is that I don't know where to start. I know how to cancel units, but I don't know where to start. Where do we start? 1.5 liters. Why do we start there? Okay, start with what's not part of a conversion factor. Fluid ounces to milliliters, that's going to be a conversion. Liters to milliliters, that's going to be a conversion. Don't start there. Don't start with the 12%. That's a conversion. Start with what's not part of a conversion. And so that's right here, 1.5 liters. So what we're going to do is we're going to write down 1.5 liters. We've got 1 liters of wine. And then let your units help guide you along to where we're going. Okay, it says the fluid ounces that we have. That's what we're trying to solve for. Okay, so I'm going to need to change liters into milliliters. Then I can change Then I can use my percentage anywhere along the line, and somewhere I'm going to go back to fluid ounces. So we're just going to write. Let's change this into milliliters. So there's 1,000 milliliters in 1 liter. Okay. And now let's use maybe our percentage, since I put it in milliliters. Now I've got this in milliliters, but we could have put this in fluid ounces. 12 over 100. Doesn't matter what the units are as long as they're the same. And so let's. So how about we'll say there's 12, not grams, 12 milliliters. So there's 12 milliliters of alcohol now per every 100 milliliters of wine. Okay. Now notice where we have milliliters of the two things, milliliters of alcohol, milliliters of wine. I'm going to label this, okay? So you can see the milliliters of wine are going to cancel out the milliliters of wine. And now at this point I've got milliliters of alcohol, okay? And then we just have one step. We need to get it to fluid ounces. So we're going to say there's 1 fluid ounce per every 29.57 milliliters, okay? And we're going to plug that in our calculator and see what we get. Okay? Anything on the top is a multiplier, anything on the bottom is a divisor. I'm going to put this in 1.5 times 1,000 times 12 divided by 100 divided by 29.57. Yeah.
So how do you know that the alcohol I know you said that doesn't matter.
It doesn't make any difference. We could have actually converted our milliliters. We could have flip-flopped this step and this step. We could have converted, let's say, our liters of wine into fluid ounces, and then we could have used 12 fluid ounces over 100 fluid ounces. So it doesn't matter what the units are. They just need to be the same. They just need to be the same, okay, for that percentage, all right? And what did we get? What did you? 6 point what? 6.1. So we get 6.1, and our units are going to be fluid ounces. Anybody else get that? 6.1? Anybody else? Yeah? Yeah. Okay. 6.1. We put that in two significant figures. And the reason that we put that in two significant, the calculator probably said much more than that, right? Calculator said what? 2 point. Okay, blah, 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 blah. Lots and lots of digits. But if you look at the numbers that we have, we're starting with 1.5 liters, two significant figures. The conversions that we have, like 1,000 over 1, are exact. They're exact. So we don't look at this and say that's one significant figure, okay? That's only for measured numbers or quantities we're given. 12%, that's two significant figures. Okay, so we're going to put our answer, when we multiply and divide, we're only good to the fewest number of significant figures. Okay, that makes sense? Okay, how about the human body contains 1.4% calcium by mass. That's by grams. Okay, how many kilograms of calcium would be found in a 225-pound person? Okay, 225-pound person. Why don't you do this one? Let's do it. And since we're talking mass of calcium and mass of body, you might want to label it as such to keep you from confusing yourself. Start with what's not part of a conversion. And then let your units be your guide. Let the conversions guide you to your answer. We're looking for kilograms of calcium. That's our answer. If you're sitting here right now and you don't know where to start, please come for help. Please come for help, okay? Because you don't understand this, okay? You need to come for help, okay? And then it'll be good. Life will be good. Did we get an answer? Did you get something? Did you get something? No. How about down on the end? Did you get something? You got 1.4 kilograms? Okay. Somebody else got 1.4 kilograms? That's a good sign. Yeah? See some heads going up and down. So we're going to start here. Where do we start? Where do we start? 225 pounds. Okay? So we got 225 pounds. Now this is body mass. Okay? This isn't calcium. This is body mass. And so what are we going to do? What's next? Well, I've got a percentage here. We could treat this as 1.4 grams over 100 grams. It could also be 1.4 kilograms over 100 kilograms. You could be 1.4 pounds over 100 pounds. We could use it any way that we want to, okay? What would come next?
435.6 grams over a pound.
Okay, so one approach would be to change pounds right away into grams, okay? So we know that 1 pound is equal to 453.6 grams, okay? Still body. This is body mass, okay? What's going to come next? So this is body, and now we can use our percentage, yes? So we could say there's 1.4 grams of calcium per every 100 grams of body. Notice that we're using grams in two different ways, for the mass of calcium, for the mass of body. So label it. Otherwise, you get your units to cancel out, but you might be canceling grams of calcium with grams of body, and that's not going to cancel. Okay? So those cancel out. We're almost there. Almost there. What comes next? Grams to kilograms. 1,000 grams in every 1 kilogram. Okay? What does that come out to be? What does that come out to be? I heard 1.4. Is that what I heard? 1.43. So now let's look at our significant figures. 225. 3. Okay? 453.6, that's a conversion, okay? 1.4%, 2. Two significant figures. So we're going to put this in two significant figures, and that's going to, sounds like it's going to be 1.4? Yeah. Is that right? 1.4 kilograms of calcium. Okay? Does that make sense? That makes sense? Okay. Let's try. This is one off of the sapling homework problem that we have. It sounds complicated, but it's not. And the one, I think this is a little more complicated than the one that they gave you. But let's look at this. A lot of words here. A lot of words here. So don't, you're looking for units. You're looking for something standing by itself. You're looking for a place to start, and then we're going to do conversions. Don't let all the words blow you away. Don't just read this and say, gee, this sounds complicated. I have no idea. You know, I don't know what to do. Okay, so it says the FDA recommends that women who are pregnant avoid eating more than 3 5-ounce servings of bluefish per month because of the relatively high levels of mercury. If bluefish contains 0.327 part per million of mercury, and they tell us what that means. That is 0.327 ounces of mercury per million ounces of fish. How many grams of mercury would a pregnant woman consume in a month if she ate the maximum recommended amount of bluefish? Okay? Where will I start?
15 ounces.
Okay, we're going to start with what's by itself, which is the serving that we've got. And I have 3 times 5 ounces. So we have 3 times 5 ounces, which so you could just say 15 ounces. Okay, now this is fish, right? This is fish. So again, we have ounces of fish and we have ounces of mercury. What's going to come next?
Would you go to the 0.327 ounces of mercury
Sure.
over top of the...
Yeah, we're gonna find out how much mercury, and they told us that there's 0.327, okay, ounces of mercury, Hg, per every 1 times 10 to the 6 ounces of fish. Okay, beautiful. Now I've got ounces, and now we just need to change ounces into? Just need to change ounces into grams. It says how many grams of mercury would they consume. So let's change our ounces into grams. This isn't a conversion that we needed to know, but in the last problem we said that a fluid ounce is equal to what? 20, 9.57? Yes? Grams. And it's not, I'm sorry, it's not a fluid ounce. This is just, oh, this isn't our conversion. This is for fluid ounces, right? This is part of the trouble with our English system that we have is we got ounces. They can be fluid ounces. They can be solid ounces. Okay? So what are we going to do? Ounces here. Let's see. We need, so this is solid, not liquid, okay? So we need to change ounces into pounds, yes? We need to change ounces because then I can go pounds to grams. Now, sometimes you're doing a problem like this one maybe, and maybe you need a conversion, you don't know what it is. Google it, okay? Google it. If it's sometimes it's not everything that's right here is given to you to solve the problem. Sometimes we got to look information up. So what's the conversion then? I need ounces on the bottom. I need pounds on the top. How many ounces are in a pound? 16. Okay, beautiful. 1 pound is 16 ounces. Okay, and then we've got a 453.6 grams in every pound. Okay, and that'll give me grams. And what does that come out to be? I'm guessing, do you think it's going to be a small number or a big number? I think it's going to be a small number, okay? And what did you get?
1.39 times 2
What is it?
1.39 times 2
1.39 times 10 to the
-4.
times 10 to the -4th grams. Times 10 to the -4th grams. It's a small value in grams, and that's why when we're talking about trace amounts of components that are there, we use terms like parts per million, parts per billion to talk about mercury. Mercury is a pollutant, so a lot of times we describe low levels of things in terms of parts per million. Okay? Did everybody get that? There's some, what we have to do here, we've got some things that we need to put in our calculator in scientific notation. Okay, so 1 times 10 to the 6. If you didn't get this, you're probably putting it in your calculator wrong. So this is we're going to put this in again as 1, and then you're going to hit the exponent button or an EE button on your calculator, and then you're going to type in 6. Okay, and then it's going to come out and it's going to see your calculator is going to say 1e to the 6. That means 1 times 10 to the 6. Okay? Do not punch in times 10 in your calculator. You'll get the wrong number every time, okay? So you can't put in 1 and then the times button and 10 and raise it to some power. You're going to get the wrong answer, okay? So just type in 1 EE. EE is the same as times 10. Okay? Does that make sense? Okay. You sure? Are we feeling better about this or worse? Absolutely not, okay? Unless it says put it in scientific notation, you don't need to do that, okay? But you certainly can. Some people come in from chemistry and it's like every single answer they got, they had to put it in scientific notation, okay? That's silly, okay? That's silly. And numbers like 35 and 0.035, those are easier for me to see and understand just by looking at the numbers rather than putting it in scientific notation. Now, some very small number or very large, we're going to want to put those in scientific notation, okay? We had a quiz today. How'd you do on the quiz? We feeling good? Okay, next Wednesday, another quiz. Okay, metric system conversion factors. Okay, your English to metric conversions, okay? So know those, all right? Yeah.
Are we going to have a conversion on the quiz, or is it just...
You'll probably have a conversion on the quiz, but it'll be a 2-step kind of thing. It's not going to be maybe 3, but it's not going to be something real complicated. Okay? Yeah. Which one?
This one?
Yeah, that's like half off.
Okay.
Yeah. Okay? All right, so let's talk about, there was a question at the beginning of class, cubic measurements and how we're going to do those kinds of conversions here. Okay, we need to have in our head a milliliter is equal to a cubic centimeter. We need to have that in our head, okay? And so a centimeter, a lot of us have done lab, okay? And if you have me for lab, we have quizzes that we do after lab. So I made a posting about a quiz that's open. That's just open. It's open for everybody, but don't take it until you've done the lab. Okay, don't do it until you do the lab. So some of you have lab today. So you're going to wait till after the lab to go ahead and do that. With Dr. Sun's folks, you're going to be writing little lab reports in your lab notebook every week. Okay? Let's see. Okay, so here's a question here. A dorm room has the following dimensions: 15 by 8 feet. 15 by 8 feet. Is that about how big is the how big are the we don't call them dorms anymore. When I was in college, we called them dormitories. Now they're residence halls. Okay, and my son is a resident director at Kent State, and he corrects me all the time. Dad, that's resident hall. Okay, so what? How big is your resident hall? What's the dimensions of your resident hall? If you live in the resident hall, some of you commute, or your room. Is that about the right size? Ballpark, maybe? Okay. So here I have, so now what we have, it says, so let's say we want to carpet our room. And we're going to put, so we need to figure out how much carpet we're going to need. And carpet by the square yard. How much does carpet sell for by the square yard? Pardon? Depends on what kind. Well, let's get a good carpet. You don't want something shabby. Well, you're students, so you want something probably as inexpensive as you can, right? $5 a square foot. Okay, beautiful. So carpet, let's write that down. Carpet is $5 a square foot. Okay, they're having a sale. Okay, and this is square foot. So this is going to be an area that we're looking at doing here. This is an area. It's two-dimensional. Okay. So we have, so the way we're going to do this, is let's find our area, okay? Let's find our area. And, and carpet, they don't sell by the square foot, they sell by the square yard. Sorry about that. So that's per square yard, okay? So it's $5 per square yard. Okay, so the question is, how much does it cost to carpet your room? If you could buy a piece of carpet that's that size, okay? So here's what we do. Figure out your area. So so the area is going to be equal to 15 feet times 8 feet. Okay? And what does that come out to be? 15 times 8? 120. And so 15 times 8 is 120. Feet times feet gives me feet squared. Okay, feet squared. So we have 120 square foot. Well, the carpet now is $5 a square yard. So I've got to convert my square feet into square yards. Okay, so here's how I do that. What we're going to do is we're going to write down, we got 120 square feet. And now what I'm going to do is I'm going to put down my conversion between feet and yards. So one yard contains
3 feet.
Thank you. 3 feet. 1 yard contains 3 feet. Yes? But 1 yard squared does not contain 3 square feet. Okay? So these are feet on the bottom, and this is feet squared. So we need feet squared. So there's a little trick that we do to be able to create that conversion. And the trick is, what we're going to do is we're going to square the top and the bottom terms. So I'm going to square this, and I'm going to square this. So on the top, 1 yard times 1 yard just gives us 1 square yard. But 3 feet times 3 feet gives me 9 square feet. Okay? So 1 square yard is equal to 9 square feet, not 3. Okay? And now our square feet are going to cancel out. I've got units of square yards, and so now we just have to use the price. Okay? So it's $5. $5 per every square yard. And that's going to cancel out, and that'll give us some dollars. So we've got 120 divided by 9 times 5. Times 5. What does that come out to be? What is it? Okay, $66 and 70 cents or whatever. Was that right? Okay, so that's what it's going to cost us. Now, in terms of significant figures, that's actually 4 significant figures. How many significant figures would I report this to? 2. we're limited by the 8 here. We're limited by the 8, okay? And so we've got, so strictly speaking, I mean, so this in two significant figures, what would this be? $67, okay? $67. All right. Why are we doing dollars? I just added it on.
Okay.
I just added on for fun. Just for fun, okay? So the problem says how many square yards are required, so all you do is take 120 divided by 9, okay? And that would give us our square yards, okay? Does that make sense? Okay. How about this one? A fish aquarium has internal dimensions of 60 by 24 by 14. Okay, so 5 feet by 2 feet by, a little over a foot. Okay? How many of you have aquariums? Anybody ever had an aquarium? You got an aquarium? Do you have one in your resident hall?
No.
Okay. How big of an aquarium do you have?
My dad has like
A 100-gallon tank. Okay, so that's a 100-gallon tank. So we fill our aquariums up with water, yes? 100-gallon tank. And so, I don't know, would this hold 100 gallons? How big is how really big, okay? Bigger than 5 feet?
Yes.
Yes, so maybe this is going to be a little bit smaller. Let's figure it out. Let's figure it out. Now here I've got 3 dimensions. I've got 3 dimensions. We've got height, we've got width, and we got length. And it doesn't matter which one we call which one. We're going to figure, so now we have volume, okay? So volume is going to be, we're going to figure out our volume. So it's going to be 60 inches times 24 inches, times 14 inches. Okay? Which gives me 60 times 24 times 14, and what does that come out to be? What is it?
20,160.
Say that one more time, I'm sorry.
20,160.
Thank you. 20,160? Now here we have more than, you can see, we just have 3 significant figures, but in your intermediate answers, just carry all the figures. You can carry all those figures along. We won't worry about significant figures till the end, when we figure gallons. So I've got this many, and my units now are square inches. Square inches. Why don't we see if we can take it the rest of the way home? How many gallons of water? How many gallons will it hold? So we're going to start with 20,160 inches cubed. Get together with your partner. Get together with your partner. Let's do it together. Let's do it.
I don't know if I did it right.
Oh, that's awesome.
I don't know if I did it right.
Okay, so after inches, where would you go?
You have to convert the inches, like do inches cubed. Did you do that?
all I've done
wait,
so
never
far.
mind. So from there you go, like 1 inch equals 2.54 centimeters, and then you
Is that
do.
one picture?
Meters to liters.
I think
Jasmine's got some good news. Jasmine, what's the news?
The 26 of you got 100s on your quiz.
26 people got perfect
There's a lot
scores.
of 95, so it was usually with fluorine, switch the O and the U around, so it's like a half a point, but for the most part, everyone did really good.
Everyone did great. That's awesome. Okay, so she's going to post those scores up on the e-learn. You'll be able to check it out later. Okay?
How do you see your grades on there?
Let's hope for the same thing on the next quiz. Okay?
I see what you're saying, because you're going to change that to a milliliter. Yeah, not milliliters for a milliliter.
It's going to involve a cubic conversion.
Okay,
And we need to go from cubic to volume.
since you need to have
So what's that key
You'll
conversion?
do this cube cube.
1 centimeter cubed is equal to 1 milliliter. 1 milliliter. We're going to need to have that along the line because we need to get it in liquid volume, not cubic volume.
I got some remembering to do.
me too. I don't know how to do exponents on this calculator.
I just did Two
even
point
know if
five
it
four
does.
times 2.54 times 2.54. I guess you just hit the EE button.
I don't even know where my EE button is.
Never mind that. That's times 10 to the. Just kidding. Don't do that. You don't know where your EE button is?
Is it that? I just got this yesterday.
I guess so.
How you doing?
Oh, here you could do exponents with this. So type it in and then hit that.
You
Yeah.
doing okay?
Cool.
Okay, great.
Mine doesn't have any.
How many gallons?
Of that.
Yeah, it's up to us.
What did you say? I think that's good. What is it exactly? Did you calculate it? Points. Okay, so you're struggling. Okay. You're not doing well.
I don't know if it's right or not.
Okay. Point 09 88.96. Okay, gotcha. Okay. So we'll see. What do we get as an answer? What do we get? 87.3. How about in the back? What you get? 80. Same thing. Okay. So here's what we're going to do. We've got a cubic. So my plan is I need to use this conversion. A milliliter is equal to a cubic centimeter. Okay, now on the test, you need to know these things. They're not going to be given unless it's something that we didn't have to memorize. But a milliliter is equal, so so I can tell, because I need that, I need to get this into cubic centimeters, right? And then I can use that conversion. So fortunately, we have an inch to centimeter conversion, right? So we have 1 inch is equal to, 1 inch is equal to what? 2.54 centimeters. 2.54 centimeters. So 1 inch is equal to that. But now I have to cube the top and the bottom because we need cubic inches, not just linear inches that we've got. Okay? This is going to give me 1 inch cubed. And then at the top, I like to write down what the number is. Otherwise, if we got a big long factor going on, we might forget to put that number in. So 2.54 cubed gives me what? 16 point? Okay, 387, so 16.39, okay? And now this is centimeters cubed. So now I've got my centimeters cubed. Now I can use my milliliter is equal to a cubic centimeter. Now I've got milliliters, and so we're just going to gallons. How do I get there? Milliliters to liters. There's 1,000 milliliters in every 1 liter. And we got one more step, then we go to gallons. I got 3.785 liters is equal to 1 gallon. Okay, everybody cancels out in my calculator. 20,160 times 16.39 divided by 1,000 divided by 3.789, and the answer is 80.7.3 gallons. Okay, and we're going to look back now in terms of significant figures. I'm going to look at the measured numbers in the problem. Okay, 60.0. How many significant figures is that? 3. 24.0. 3. There must be a reason somebody wrote 0.0 and not just 24. So that 0 afterwards is significant. 14.0. So they're all in 3 significant figures. So we're going to report this then to 3 significant figures. Okay? Does that make sense? Okay, now you were close. You were 88.01395, whatever. So what was different with yours?
I changed inches to centimeters,
Okay.
and then from there, just
Then you did it. That's another way of doing the problem too. The other way of doing it is just to take, you've got all these measurements in inches. So if you're not sure about how to do the cubic conversion, change all those into centimeters. Takes a little more work, but we could have changed all those into centimeters, multiply them together, then we got cubic centimeters, and then that's how you did it. Perfectly fine, okay? Okay.
so my answer was different, obviously.
Your answer was a little different due to the number of figures that you carried when you did that conversion. You know, when you did each of those conversions, okay? But on the test is going to be multiple choice, and so maybe one of the answers is 87.3, maybe one of them is 102.5. It's not going to be one of them is 88.013 and 87.3. They're going to be, differentiate by quite a bit, okay? Okay, does that make sense? Okay, this whole business about measured numbers, accuracy, significant figures, we're dealing with that a little bit in the lab. We're not going to take time to cover that in class. There's a video out there. So I've got some tutorials both on how we recognize significant figures and then how we use them in calculations. So make sure that you watch those, okay? Make sure you watch us. Temperature, we just have some simple conversions, some formulas that we need. I'll put a video up there on that, okay? On how to do that. Density is mass over volume. And so in lab this week, we're going to be measuring the masses of things on balances and figuring their volumes. Sometimes the volume of a regularly shaped object is we can just use a formula, like if it's a sphere or if it's a cylinder, we can use a formula to calculate that. If it's an irregular substance, we're going to get it by water displacement. Okay? Density is typically for liquids reported in units of grams per milliliter of liquid, like water. Water has a density of what? 1 gram per every milliliter. Okay? So if you got 20 grams of water, that would have a volume of 20 milliliters. Okay? Solids tend to be in grams per cubic centimeter, and gases tend to be in grams per liter, because they take up lots more space, okay? So density is a real important physical property of materials, okay? And the density of a substance changes when we heat it up because the atoms get a little farther apart, and that's going to change their volume. Their volume is going to increase, so the density is going to get smaller, okay? Okay, what is this trying to show me here? You probably see it better on the TV. We got a beaker here, and it's got some stuff. So we got some stuff floating. We got some... Okay, it shows aluminum and lead that are sitting at the bottom of this. Water has a density of 1 gram per milliliter. If something has a greater density, it's going to sink. If something has a lower density, it's going to float. Yes? I'm sorry?
My arm is just sore.
Oh, your arm is just sore. Okay. All those chemistry problems you worked last night, right? Yeah, okay. Okay, so some of the questions, there's a question on the quiz about objects floating and in the lab quiz about floating and sinking and that. So if it's got a greater density than 1, it's going to sink, okay? Smaller one, it's going to float. Here's some density of different objects. You can see solids tend to have the greatest density that's here, followed by liquids and followed by gases, okay? And, okay. Okay, let's take a look at this thing right here. I've got a little amusing video. This is sulfur hexafluoride. Have you ever taken a balloon full of helium, and we have helium balloons at birthday parties, and inhale that? What happens?
Squeaky.
Your voice gets squeaky. Does it get higher or lower? Higher. Why does it get higher?
Because there's a lower density than actual air around you.
Because that helium has a lower density, okay, than the air around you. And your vocal cords vibrate a little faster and you get a higher frequency. This is sulfur hexafluoride, SF6. Okay, which is a chemical compound. It's a gas, but it has a high density, about 5 times that of air. Okay? And if we get it to play, it will be interesting. Go ahead, while we're getting this up, go ahead and get your what do we? Socratic. Thank you. Get the Socratic out there. Take a look at this here. Take a look at this while you're doing that. You're going to miss it. So here they've got a gas. They've got an aquarium. okay, that they filled up with sulfur hexafluoride, okay? And they've got a little boat they made out of aluminum. We don't want that. What happened to my other? Okay.
Hi, my name is James Lincoln, and this is one of my favorite experiments.
Oh, come on, we don't want this. We want here. Let me try to find a better one. I thought that.
Everybody knows what happens when you breathe in helium.
The sum of the squares of the legs of any right triangle is equal to the square root of the remaining side.
And many people know what happens when you breathe in sulfur hexafluoride.
We hold these truths to be self-evident that all men are created equal, and that there are no men are created with certain unusual rights, and among these are life, liberty, and the pursuit of happiness.
Now, helium raises the frequency of your voice because it's less dense than air. And sulfur hexafluoride is more dense than ordinary air, and so it lowers the frequency of your voice. Sound waves travel faster in helium and slower in sulfur hexafluoride. But what happens when you breathe them both in at the same time?
What will happen?
They'll bounce themselves out, and then, well, first you'll get the helium coming out, and then you'll get the sulfur hexafluoride.
Happy birthday to you, happy birthday to you, happy birthday dear Einstein, happy birthday to you.
The mixture of equal parts helium and sulfur hexafluoride resulted in an average density that was still denser than that of ordinary air. Therefore, my voice was still a bit lower than normal.
Okay. Chemistry's all around us. Does that make sense? Okay, so this is just the density of gases. Okay, we had our first quiz. We've been working on these factor label things. You should be halfway through your practice problems. You should be done. You should be a good way into sampling by now. If you're struggling, if when we put these problems up, you're just sitting there staring at your paper, don't know where to go, or you wrote down the first starting point and then we don't know where to go, please come and get some help. Please come and get some help, and your life is going to be so much easier if you just come and get some help. Don't be afraid, okay? I have, so come and see me, come to the sessions that we got, but come and get some help, and things will be fun, okay?
I'm having a study session tomorrow at 6. It's going to be strictly like practice problems. So come with questions, please.
Is it in this room?
It'll be in the same room we had the other one.